Assalamualaikum and good day everyone. Okay, today we're gonna go through our chapter 9, which is numerical differentiation. Okay, before this, if you want to find the derivative for your fx, let's say for your fx 2x power 3, if you want to find the first derivative, you can do it directly, right? But this you learn in your calculus class before. Here we will learn to do it using numerical method. We learn to find the derivative, let's say the first derivative and the second derivative using numerical methods. So again, this chapter we will not teach you about this. We will teach you how to find the derivative, the first and second derivative using numerical methods. That is what we're going to learn in this class. Okay, why we need to use numerical method to find the derivative? Usually in real world application, right, the functions sometimes are unknowns. You do not know the fx here, you do not know. Okay, and sometimes it is difficult or impossible to differentiate. Sometimes the function is too difficult to differentiate. This is the real world. Okay, the real world case study. But in this class, we will not use difficult function. We will use an easier function. All right, because the objective of this class is we want to learn how to use numerical methods. And one must be very careful when using numerical techniques to estimate the rate of exchange of measured data, since small errors are exaggerated by differentiation. So you must be very careful using the numerical techniques. There are several formulas for approximating a first and second derivative, and we use one of them, which is Taylor polynomials. Okay, this is the Taylor polynomials. Okay, so there are many formulas, but for this class we will use based from the Taylor polynomials. Okay, to find the first derivatives using the Taylor polynomials formula, we have three main point formulas here. The first one is the 2 points. In the 2 point, we will have a forward and backwards difference formula. Okay, so these two already get 2. For the 3 point formulas, we have 3 types: the forward difference, backward difference, and central difference. 5 point formulas, we will have 2 forward and central different formulas. So this 2, 3, 7 formula here is used to find our first derivative, which is our this one, f prime x here. This is used to find the first derivative. Okay, all this formula is based on the previous Taylor polynomials, the infinite Taylor polynomials. Okay, we start with the 2 point formulas. All right, this is given to you the first type, which is the forward difference formula. Okay, this is the derivation of the forward difference formula. Okay, and as you can see in this class, we will not emphasize too much on the derivation of the formula. Okay, in this class we will use the formula that have been derived, which is this one here. So this is the formula for forward difference that we will use. We will apply in this chapter. Okay. Okay, but basically you can see how, for example, the forward difference formula is derived here. Okay, this is based from the polynomial, the Taylor polynomial, right? But we added h. H is the difference that we will see in the next example. So we want to find the first derivative, right, here. So we stop until now here. This is the second derivative, third derivative. Okay, so we stop here. Then we need to make this as the mean here. and then we change there. This one we make it on the left, right, so this one move to the left, so we got n divided by h, so we got this. Then you will get your final formula for forward difference. Okay, this is how you derive the formula, but for this class we will focus on how you want to apply the formula that have been given to you. Next, we look into the backward difference formula for 2 point. So this is how you derive the backward difference formula. From this, again, this is from the polynomial and h is the difference, right? So you can see how they derive in the formula here until you get your backward difference formula that you need to use. Let's look at an example. They give you a table here, alright, and they ask you to use forward and backward 2-point formulas to estimate f for first derivative of 1.05. Okay, this is the example where we don't know the fx, we don't know the functions, alright. This is the example where we don't know the functions. They don't give you the formula for the functions here, but they give you the data. So in this case, if you don't have the functions, how can you find the first derivative, right, directly? Okay, because you don't have the function in the first place. That's why in this case you need to use the numerical methods, where they give you the data and then you need to use the numerical method to find the first derivative. So in this question, we want to find the first derivative of, at this point, 1.05, which is here. First derivative 1.05. As you can see, the point here must be in the table. If it is not in the table, we cannot find it. Okay, this is not like the last chapter. Okay, for this chapter, you want to find the derivative. The point must be available in the table. Okay. Alright, it is different from our last chapter. Last chapter, interpolation, we want to find the value of the points in the table. But now we don't want to find the value of the one that is not in the table. We want to find the first derivative. Okay, so it is different. Alright. So the point must be inside the table so that we can use the numbers here, the fx. If it is not in the table, we don't have the fx. Last chapter, interpolation, we want to find the fx for the point. So it is different problems. Now, to use this table to find the first derivative, okay, as you can see, we have 2 points here, so we need to have 2 points. For forward, in order for us to know how to use the forward and backward formulas here, we need to identify the h. Okay, what is the h? H is the difference between these two, the difference from each of it. So the difference is 0. How much is the difference here? 0.05. Okay, this is the h, 0.05, 0.05, 0.05. Okay, so the h is 0.05. Okay, because you need to know the value of h. You need to know the value of h, and you need to know the value of x. Okay, this one here, the x is 1.05. This is the x. This is the x. If let's say the equation, if you look at the forward and backward of this, let's say x plus h. So 1.05 plus h is 0.05. Right, so u equals to 1.10. So this one. This is generally, okay, I speak. Let's say x minus h. Let's say the equation, you will see this, x minus h. So x is what? X is the what equation 1 here, 1.05, minus h is 0.05, which is 1.00. Right? Let's say after this you will see if we go to 5 points, x plus 2h. So your x is 1.05 plus 2 of h, 0.05, which is equals to 1.15. So this one. Right? Because the equation, there we use the value of x, x0 sometimes, x, and h. So if you know x and h, you can find at which point that they want. Alright, for example, we see the equation next. Okay, here, this is the forward difference formula. As you can see, this is the formula that we need to use. Right, so fxi plus h minus fxi. As we know, our xi is 1.05 based from our previous question, right? And our h is 0.05. So when we know, we just put into the equation here, 1.05 is the x and this is the h, right? This is 1.05 and this is the h. Then you do the calculation for the 1.05, the f prime for the first derivative of 1.05, and you get your answer 0.4822. So as long as you know how to find this value, x plus h, fx, the h, then you can answer the questions. Just follow the forward difference from the formula given to you. For this one, this is the forward difference formula. Let's look at the backward difference formula. This is the backward difference formula. Alright, so the fx in front and then the fx minus h. Again, we know our xi and we know our h based from the previous table, right? So this is our x, this is our x, this is our h. So we put into the equation, we find this equation here for backward difference formula, and this will be your final answer. So as you can see, for the forward difference formula, the point and in front of it. So this is 1.05, this is 1.10 actually. That will be in the forward difference. But for backward difference, 1.05, 2 point, okay, 2 point, 1.05 and 1.00. So these two for the backward difference, 2 point. Okay, the one that they want, 1.05, the next one for forward difference. For backward difference, the one that they want actually, and the previous one. If you look closely on the equation that has been given to you. Now we're going to 3-point formulas. Okay, this is the derivation of the formula. Okay, and at the end, we will use this formula to calculate the 3-point formulas of forward difference. Then we have backward difference, saying this is the derivation of the formula. Okay, and this is the final formula for the 3-point formula's backward difference that we will use. Next one is we have one more in 3-point formula, which is central difference formula. This is the derivation of the formulas, and you can see we have only two here. This is the final formula to be used, and we have two, xi plus h. Even though this is 3-point formulas, for central difference, it is different from the forward and backward. If you see forward and backward before, we have 3 types of points, but because this is 3-point, right? But for central, we only have 2. The one in front, xi plus h, if you remember, h is in front, right? One, and this is minus h at the back. So there is no the point itself. Okay, we'll see in the example. Okay, They give you the first example here, use forward, backward and central 3-point formulas, and to estimate the first derivation of 1.10 at 1.10, which is this one. Alright, so for forward, backward and central, actually because this is 3-point, right? So forward, this is the first point actually, this is the second point, and this is the third point. So 1, 2, 3. For backwards, this is the first point, this is the second point, this is the third point. You can see the theme now, right? For 2-point, the first one and at the back only, but for 3-point here, we move another here. Okay, as we can see in the equation after this. For central, we don't have this one, we only have 1.04 because this is the point, right? So we only have 1.05 and 1.15, as I mentioned before, only 2 point. We don't have point for itself. So remember this 1.10, okay? And the h is between this one is 0.05. Okay, remember this, right? As we go to the question, right? To solve the forward difference formula first for 3 points, okay, we see this is the equation that we need to use. Okay, this is constant, right? You need to have this -3, 4 inside the equation. Okay, so the xi is 1.10. We know that our xi is 1.10 and the h is 0.05 based from the question. So just put into the equation here, h is 0.05, xi is 1.10, xi 1.0 plus h, so one number in front, and xi plus 2h, so 2 number in front. So we have 1.10, 1.10, 1.15 and 1.20, 3 points. Okay, and then we find the effect, we put the effect into the equation, so you get your answer. Next, for backward difference formula for 3 points. Okay, the backward difference formula for 3 points here. As you can see, this is the equation. Okay, so this is the minus here. That's the difference, right? So you just put the h, same thing, and this is your x, and minus 2 multiply 0.05. Alright, second one is minus 0.05, and then our xi. So the f here 1.10 minus 0.10, which is it will be 1.00, right? And then next one 1.05, and this is our xi 1.10. So 3 points, 1.10, 1.05, 1.00 from the table. Okay, if you remember before this, the forward difference we have 1.15, 1.20. Okay, so this point must be inside the forward and backward difference formula for 3 points. And then we substitute with our fx, do the calculation, you will get your answer. Now we see the central difference formula. Okay, if you can see clearly, we only have 2 points here, the one in front and the one at the back. Okay, just put into the equation, this is 1.10 and our h, 1.10 in our h. So the answer actually is 1.15 here, 1.15 plus, right? And then the minus is 1.05. There is no the xi only, 1.10 if you remember. There is no 1.10 inside central difference formula. We only have 2 for the 3 points here. Okay, this will be the central difference here will be different in our second derivative. This is our first derivative. We find our first derivation. Okay, you calculate and you will get your answer 0.4768. Okay, now we come to the 5-point formulas. As I mentioned before, the more point you have, the more accurate the calculation will be. But the formula will be much more complex and the calculation will be much longer. Okay, that's the drawback. But your calculation, the error will be less compared to the 2-point and 3-point usually, because this involve so many points compared to before. So this is the forward difference formula for 5 points. Alright, you must use negative 25, 48, 36, 16, 3, all must be inside the, this is constant, it must be inside the formula. And then for the central difference formula, so you can see here, this is your xi, as it is a forward, plus 1, 1 after the xi, 2 after the xi, 3 after the xi, and 4 after the xi. So we have 1, 2, 3, 4, 5, 5 points. But for central formula, same as before, okay, but this time not 2, but only 4. So the 2 before, 1 before the xi, 1 after the xi, and 2 after the xi. Okay, so we don't have the xi inside the calculation of the central difference formula. Okay, this is the example. Same thing here, we don't know our fx, right? Same theme here. So they ask us to use forward and central 5-point formulas to estimate at this point the derivation, the first derivation of 1.10. Okay, so we can directly see, okay, this our h is 0.05, right? And then this is your x0. So your 5 forward, which is 1, 2, 3, 4, 5. This will be your point actually. Okay, you can go too fast after this because we already, I think you already know how to calculate the plus h and plus 2h, something like that, right? For central, this 4, 1, 2, 3, 4 will be inside our calculation because this is our x. Now the forward difference formula, we have, this is our h, so this here they go fast, they just insert the value inside the equation. So the xi is 1.10, and this is your h, and this is your xi, xi plus h, xi plus 2h, xi plus 3h, xi plus 4h. Okay, so you put into the fx to the equation for each of the points here, and you will get your answer. Central difference formula, same. This is the point that you want, 1.10. This is your h. This is 1.10 minus 2, 0.05. Okay, this is the two previous one, and then the previous is 0.05, and then plus 0.05 and plus 2, 0.05. So you will get actually 1.0, 1.05, and 1.15, 1.20. There is no xi. There is no 1.10 inside the calculation here. The point only 4. Okay, for central difference formula, the point inside the calculation only 4. So we put in the fx for each of the points based from the table, and you will get your answer. Okay, as I mentioned many times previously, in general, using more valuation points with small values of h produces greater accuracy, but you will need to calculate even more complex equation, and it will take more time. Okay, now we come to the second derivative. Okay, in this second derivative, we will only cover two type of point formulas. One is 3 point and one is 5 point. There are many more, but we didn't cover in the in this section in this class. So for 3-point formulas, we have central difference formulas, and also 5-point formulas, we have the central difference formula for both. Okay. Now the 3-point formulas. All right, this is the 3-point formulas derivation. Okay, for the second derivative, the second derivative here. Okay, not first, second one. All right, and then as you can see, central means that if you see before, for the first derivative, right, we have only 2 points for central, but in this one, for second derivation here, second derivative, we have 3. We have the one before, the one after, and also the xi. Okay, we have that in the 3-point formulas for the second derivative. All right, so here's question, same here, we don't have our fx. Okay, So use central 3-point formulas to estimate the second derivation at point 1.10 with h 0.05. So this is 1.10. Okay, as this is a central 3 points, so we use central 3 points for the second derivative here. So we need to use 1.10, the one before 1.05 and 1.15. Okay, now this is the equation before. So same as previously, we just insert our xi. The xi is 1.10. So the previous one is 1.05 and this one is 1.15. So you put into the you put the fx into the equation and h here, and you will get your approximation of your second derivative. Alright, this is the central 5-point formulas, 5-point difference formula. Okay, as you can see, same as previously, now we include our xi. So we will have 5 points. Okay, the xi, the one previously, and the 2 times previous one. Alright, and then the one after it and the 2 times point after it. Okay, so we have 1, 2, 3, 4, 5. 5 points for central 5-point difference formula for your second derivative. For your first one, we only have 4 because we don't have the xi. Okay, use central 5-point formulas to estimate your second derivative, which is 1.10. So this is our 1.10, right? So 5-point formulas for second derivation. So second derivation, we need to include our xi, 2 previous one, and 2 after it. Okay, this we need to include in our equation. So this is our equation. Okay, so put our h inside here, and this is our xi, and this is 2h, xi with minus 1h, our xi plus h, and xi plus 2h. So actually you will get your xi 1.10, and then 2 previous numbers, and 2 after 1.1, 2 numbers after 1.10. Okay, again put into the equation the fx, and you will get your approximation of your second derivation.